Okay, we'll get started with the panel session. We're going to go over some questions regarding about what challenges still need to be solved in the drill bit space, where investment dollars should go, and then a question on how should we be making drill bit decisions. The panel has got 3 people on it. We got Gabe Diaz, drilling engineer at Pioneer Natural Resources. On the drilling optimization team. Gabe, prior to that, was a application and design engineer for Halliburton drill bits. Gabe's got a little over 9 years of industry experience. Dustin Cashel is joining us from Shell. He's a directional and performance drilling SME. He's responsible for global wells of significance and ad hoc operational support for Shell's shale business, primarily focused in the Texas-Delaware Basin. Dustin's got over 15 years of experience. And then Paul Pastusik, who's a drilling mechanics advisor in wells of technical organization at ExxonMobil. His experience covers just a wide range of drilling functions. He is a registered professional engineer and has well over 40 patents and delivered papers and presentations. So great panel that we have. The way we're going to kind of run through this is we'll go kind of question by question and let the 3 panelists give some responses to it. And then just like in the last presentation we had, we'll have room for questions and stuff like that at the end. So if we would, the first question we ask, if Paul could start off, and we'll kind of go Paul, Gabe, and Dustin and work ourselves through it that way. So Paul, what challenges still need to be solved with respect to drill bits? What still lies out there?
So, yeah, what you've got up there, I think, is a combination of Dustin's and mine and Gabe's comments, but just to say a couple of things that I think that are really essential. You guys probably know I'm a big fan of understanding cutter fracture toughness, particularly in the tangential direction. If just fundamentally, if you look at most of the failures we see today, we break cutters in half. We break them back through the carbide or we crack them. They're loaded in that cutting direction. And historically, we have not really addressed that when we talk about, somebody says, hey, this is my most fracture tough cutter or whatever. They really haven't always measured in that direction. It is a fracture toughness thing. You can see pre-existing cracks or cracks that form, and then you have to propagate them all the way through. So I'm a believer in fracture toughness in that regard. Related to that is that today the bit information sheets that are sent out say I have a certain weight on bit RPM recommendation, and the problem with that is if I'm drilling interbedded formations, I don't have to exceed, let's say, 30,000 pounds. I never exceed 30,000 pounds, but yet I break cutters, and because it's that tangential load exceeding the depth of cut in those interbedded formations. So I am really seriously promoting that we need to change the way that we address drill bit design and cutter selection to be one of depth of cut and formation strength based on the structural integrity and based on that fracture toughness. That's my #1 today thing on what we need in terms of drill bits. I also see later in the discussion here is around getting continuous improvement. David Hutchison said it. I am a huge fan of relentless redesign, continuous improvement. For that, I see quite often limited capability of doing forensics at the rig site. Yes, we can do forensics back in an office environment, or when it gets back to a plant. The problem is that if I'm going to put another bit in the ground, wouldn't it be nice that I make a decision right then when I pull the bit out and I look at it and I say, I've got 3 to choose from. Here's the failure. Here's the reason. Here's what we're going to do to address it. So I really think we need to make sure that people at the rig site actually understand forensics, not just dull grading, but true forensics of getting to the root cause and understanding that. So I'm a firm believer in that. The last one that, I'll let the other people talk here a little bit. The last one before on this one slide is, so ExxonMobil has a set of bit selection guidelines. And so my comment here was to train all field service employees to follow the customer's guidelines. Well, I really want you to follow ExxonMobil's. We have a relatively complete set of checklists that we look at. Once we get involved with a vendor in a given area, we go into a new area of drilling, it's no problem. We really do get what we want. And I think it is, David, you said it right. Yes, everybody's a drill bit expert, and boy, we think we are too. So, but yeah, we do have a lot of things on our checklist. What is frustrating is that the first proposal that comes back is quite often not following some of the most fundamental guidelines that we already know. And after about 2 or 3 iterations, yeah, we get down to something that they like, we like, and everybody's good. But it's really surprising, if you will, that we have to do that so many times. So that's probably my number 3 deal there is around making sure that everyone that's customer facing understands what the customer's requirements are if they've got special needs. That's been an issue with just about every vendor. It's been really hard to maintain that. So I'll quit and let other people talk, and then we can talk about some other things.
Gabe, do you want to pick up where he left off? You'll have to unmute Gabe if you're on.
Can y'all hear me? Am I echoing?
We can now. Yep.
Okay. Sorry about that. Yeah, I can. I was just started off saying that I agree 100% with what Paul was saying. Pioneer actually kind of implemented some of Exxon's principles, fast drill with gauge lengths and what we expect on depth of cut control and relieved and stepped gauges so we can get build rates and things of that nature. I agree 100% with him on that. On our intermediate bits, I think we've kind of done really well handling the transitional environments and the rattiness of West Texas drilling. I think one of the bigger challenges from a PDC design specifically that we still need to work on is we're pretty much 100% shell play now in West Texas, but we still have issues when we hit carbonates at a really high angle. And so shoulder and gauge still kind of get beat up quite a bit. So I think we have to have a better understanding of how those bits are engaging the rock. We can very easily understand it in vertical hole because you're hitting kind of like that brick wall actually. But in the lateral, if you intersect a carbonate, it's at a very, very, well, actually it's a very low angle of attack, 2 or 3 degrees of dip versus your 90-degree inclination. So we still have a lot of issues like that. And the way we kind of try to deal with that is just carbonate avoidance altogether, but we still have a lot of interbedded formations. And I think that's still a struggle that we have, at least from the Pioneer side, of getting bits that can handle highly transitional environments, specifically in the lateral. Not so much in the vertical now. I think they've done a really good job of handling transitional drilling in the vertical, but now we're having to deal with those situations in the lateral where we're not traversing that carbonate head on at the nose first. We're actually kind of hitting it at a very low angle. So that's kind of one thing I think from a bit design perspective that we kind of need to work on a little bit more. And we still have, those DBRs. And as far as like the challenges that still need to be addressed, I agree with Paul. Dealing with salesmen on a front-to-front basis, sometimes the conversations kind of are only 2 or 3 minutes before you realize that you need to talk to somebody else on what they recommend. Or I think having the people that are interfacing with the operator, the more technically savvy they are about their products, I think the better that will be, and the better bit will go on the ground. You'll have fit-for-purpose applications. And I think one thing that we need to do from we represent like a small, like we're not an Exxon or a Shell or Chevron where we have a ton of rigs. There's 400 rigs in the Permian in like the presentation last. It's dominated by 4 or 5 major bit vendors. there's a lot more leveraging of data and resources that need to happen. The learnings are vastly accelerated when you compare it to like a Pioneer, where we only have, say, 10 to 20 rigs operating, where you might have 100 rigs that a drill bit company's on in a specific area. So they can learn the lessons a lot quicker than kind of these smaller mid-major operators. And I think that is still an issue, is that there's not leveraging the resources and the amount of data and lessons learned that happen over all the different operators. So like the challenges that we're seeing aren't unique to us. We know that other operators have to have those same challenges. So I think leveraging those resources that those, the majors have, like the Schlumbergers, the Bakers, and the Halliburtons, that I think instead of being so siloed with the information and the lessons learned, I think we could we can learn from that as well. And I think from that, so those are some of the challenges I think that, drill bits still can address and focus on specifically on the bit design and the laterals when dealing with carbonates and stuff, but also just leveraging those lessons learned because of the acceleration that you have from the lessons being provided. So that's I have other things to talk about, but I kind of open it up from there.
Thanks, Gabe. Dustin, there's still some meat on the bone. If you want to.
Yeah. Can you hear me all right?
We can.
Okay, perfect. Yeah. Well, I just want to say, I'm not going to disagree with anything that Paul or Gabe has said here. In general, I think what makes drill bits so fascinating is that there is still so many challenges to solve, and why so many of us are passionate about it. Those of you who know me probably recognize a few of these bullet points, came from myself. But I'll try and balance some of my comments toward the U.S. land market, but also touch a little bit on the international market. I would say overall today, my biggest thing that I need, or that needs to be addressed, is collection of data and tying it back to the forensic evidence of the drill bit. So getting good, clear dull photos and drilling performance data from those runs. Still, way too often we get pictures taken at nighttime, out of focus, or dirty bits with OBM or dry brine all over them. You can't see the cutters. In U.S. lands, the majority of the drill bit vendors are only getting what's being referred to as IADC hours, so total hours from spud to TD, which really has very little value for me in terms of benchmarking drill bits against each other. And that's a long ways away from, having the ultimate goal of, being able to produce like a bit aggressiveness coefficient for the bit, and then benchmarking that versus other runs. Yeah. Okay. Data. That's number one. There still exists, quite a few plays internationally where cutter wear is a very large problem. These are generally in abrasive sand reservoirs or larger diameter sand intervals, where it becomes a lot more important, I guess, if you will, to have a better understanding or be able to upfront model the efficiency of these bits in the various wear states, and sort of come to a better estimate of the total cost of ownership or the total performance for a given amount of distance. I feel like in general, with a few exceptions, the industry is still pretty far away from being able to produce those results pre-run. Where else did I want to go with? I think there was some touch, amongst gauge lengths and gauge tapers geometry, and how that affects overall steerability. I really do think that there still is a lot of misconceptions out there still in this topic, despite a great amount of papers, some from who are on this panel. That we really need to get a better link up with directional drilling and bit gauge lengths and profiles. We got to fix that gap between ourselves. It's not super difficult. We can do this. Overall, I have similar comments towards my interactions with vendors. Shell as well does have a checklist for bits, but often, during the RFP process, or just a general sales call, we're pretty far away from what we're looking for an ideal product, and sometimes parts of that checklist need to be tempered for given applications, but often things that we just shouldn't do still are being proposed, and that is an area of focus for sure. Have I used all my time, Matt, or I think I hit a few of the important things in my mind. I guess just another thing that is starting to become a point of note for us is the proliferation of high frequency data sensors, as for logging accelerations, and now as well forces. It's great to have all this data, but as was mentioned before, there seems to be no defined workflow really on how to use that data. We can get a couple insights, but I think we really need to close the loop on how we're going to use that data for a redesign process when it comes to actual attribute modifications for the drill bit. I think I'll leave it there.
Okay, no, thanks, Dustin. And we'll kind of mix up the order on the second question, and it kind of transitions us there. So stepping out of like current challenges that we talked about, let's move on to future challenges that you see out there. Where do the investment dollars need to go from the drill bit companies? Gabe, if you'll start us off on this one, then we'll go Dustin and Paul.
Yeah, it's all right. Kind of had to find the mute button. So during the environment that we're seeing now, I'm going to kind of take a step back real quick before I answer the question. I think the most critical thing that we can have currently, we have a good stable of products, I think that most vendors are supplying, but QC and quality assurance still need a primary focus in manufacturing and repair. So the dollars, I mean, there's a huge downturn and there's a lot of cuts that probably have to be made by necessity, but the main thing is like, I wouldn't cut spending on QC and QA, especially manufacturing and repair. And that, I'll leave it at that from the dollars spent. But as far as future technologies, I think we've already kind of talked about it. 15 years ago, if I would have told you your cell phone would cost $1,000, you would punch me in the face, because nobody would expect that. The cell phone, you didn't even have a calculator on it back then. It didn't have a phone on it. You couldn't check your emails. You couldn't browse the web. And the bits shouldn't be used just for cutting rock. There's so much advantages of having those near bit sensors at the bit. And we don't even have to talk about shock and vibe. You can put a PWD in there and get at bit ECDs and temperatures and pressures, and there's a lot of meat on the bone if we future investment dollars on these things, from the not even from the bit side itself, but just from the overall drilling environment, knowing when that sweep hits your bit and you're able to capture that data. And like, there's so much that could be gleaned from these that bit sensors outside of just the cutting rock aspect of the bit. You kind of, that's the analogy I'll take is the phone. We hardly ever use our phones for phone calls anymore. I think that the bit could be that way too. And then as far as gaining that capital back, like I said, if you wanted to spend $1,000 on a cell phone now, you kind of don't even blink an eye at it. You just go and buy it because of the value that it brings. And so with these at-bit sensors and leveraging that technology and using that real estate, the closer we are to the bit, the actual true weight of the bit, so we can, if we're able to pulse that up, and we'll know when we're fully locked up, if we're actually transferring weight, when we're sliding. There's so many things that we can do with that if we're able, one, like Dustin said, to like leverage the data and actually use it. There's a huge potential there, and obviously this is like years out, but that's where I'll say that we need smart bits, and it's not, we call them smartphones, and we don't even actually use them to make phone calls. And the same thing with smart bits, it's like, yeah, there's all this stuff that we can do with it, and oh, by the way, it's cutting rock. So I think that's kind of one thing that we can do and use our resources for that. And y'all would have to get with the operators and get these tests done and like get through those growing pains of failures and all those things. But I think you can find operators once you show them the value that it's huge potential there, no doubt. That's all for me on that.
Thanks, Gabe. Justin?
Wow. Yeah, tough act to follow. I'm going to go a little bit rogue here and say the best place for drill bit companies to throw their CapEx right now is in R&D towards shape design, so shape cutters. The proliferation of non-round cutters into the drill bit space, I think has really only just begun. We've seen some massive improvements with the various shapes out there in a multitude of applications. I think it's going to be on the drill bit vendors to figure out how to remain profitable with some of these shapes, but I think we're just only in the infancy of understanding, what we can do in that space and what shapes are best for what type of applications and confining pressures and fluid types and lithologies that to me is the number one most exciting piece in terms of what the future has for drill bits. I think another probably going against the grain. I really believe that this is a great time for the larger organizations to step up with training when it comes to their personnel. So often we have groups and centrally managed groups from the big drill bit companies with an incredible amount of expertise and knowledge, where it doesn't always get to where it needs to all the time. I know each company has their own initiatives, whether it's it's calls with their regional designers or bulletins or just sending emails. But with the amount of personnel reduction that's taken place, I think it's a great time to redouble your efforts and make sure globally we're sharing everything we can in terms of knowledge. We shouldn't have a massive gap, in competencies, from Asia Pacific to North America. That just shouldn't be happening. What else do I got? Paul already hit on it, but tougher cutters, more tangential fracture resistance. That's going to be another key enabler for a multitude of applications. You know, we've nailed wear so down to a very small amount of applications these days, and really the aggressiveness of bits is limited, you know, to in general by how much diamond volume we put on these bits, and that's often driven by the requirement to not break cutters. So if we get stronger cutters, we can run with you know, a lower cutter density or even perhaps a larger diameter cutter, and that's going to drive down costs immensely. Okay, I think, yeah, those are my top three, I guess.
Paul, we'll see if Dustin left you some room for some more.
Well, he and I agree on so many things. It's actually hard, but that's okay. I'm going to say them anyway. I have four things. My number one is training, and that's exactly what he said. We have a rate of learning in this organization, in this world, and we have a rate of forgetting. These disruptive times like this, you guys have lost 30, 40% of the workforce. Those that you didn't lose, you've transferred around and moved them from one location to another, or one job family to another. It is catastrophic what we lose in terms of the knowledge that is, again, I'm gonna call it customer facing. So boy, if I had a drill bit company and I were investing my money, the number one thing that I would do is make sure that the frontline guys and girls knew absolutely everything they could possibly know about the physics of drilling, about how to interact with customers, how to get to their root cause, root problems, etc. So that's my number one. My number two is around modeling. I've been promoting open source modeling for a while now. When we talk about modeling, there is, in the electronics industry, there's a program called SPICE. It goes back all the way to the 1970s. SPICE is a simulation program with an emphasis on integrated circuit, or with integrated circuit emphasis, so SPICE. That program allows people to plug in different elements. So I can have a drill bit design, I could have an agitator design, I could have some kind of a stick slip sub or anything else, and I could put all those things together and model the drill string just like they model the electronics. I mean, the worst thing, can you imagine that if the way we do the drill bits is we stick everything together, drill bits and the VHA, and we put it in the ground and see if it works. And my analogy for electronics is, well, let's put a capacitor here, a resistor here, and let's put a little transistor there, and we'll plug it in and see if it works. And if smoke comes out, we go, oh, well, let's don't do that. Let's change something. And we have the ability today to model all of that. Now, not a drill bit vendor may not know how to model the control system on a drill rig, but the control guys do. So let them do their part, do your part on drilling. As far as the bits modeling itself, the emphasis that I want to put on is a couple of things. One is aggressiveness, or stick slip modeling. How aggressive do I need to be? Do these little depth of cut elements help? I see a lot of people going, even today, I had it just the other day, had somebody propose a 10-degree back rake cutter, which is very, very fracture prone, and trying to make a bit more aggressive. Well, right until it breaks, that's probably true. But some of the, in terms of modeling its ability to cut both forward and to the side, and I think Dustin said it as well, which is, the modeling the side cutting capabilities so that I know what I need for a given rotary steerable or a given motor assembly. Interesting comment on cutter modeling. So this is kind of relating to modeling as well. It's interesting. I don't actually care as much about CFD as you guys do. Computational fluid dynamics, where all the fluid goes and everything, is kind of cool. It's been around 20, 30 years now, 30 years probably at least. That's true. I do need to kind of know where the fluid goes. But you know what I really care about is, where do the ribbons go? Where do the ribbons and the chips themselves go? And again, when you're talking about shape cutters and these front shapes, If I split the ribbon, does that help me? Is it going where I want to go? And boy, you guys know I teach, and I have a lot of little tabletop demonstrators. One of my old tabletop demonstrator is a 2-cutter drill bit that I machine or drill into paraffin, which behaves real nicely like rocks under pressure. And I use that to describe, it is a physical model, but I use that to describe the chip flow process. So I think essentially being able to model where the ribbons are going and knowing that, I cannot tell you how many bit designs we've rejected from really good, reputable companies, even recently, because they didn't allow for any place for the ribbons themselves to go. So there's several really good papers out there on chip flow, rock mechanics, cutting mechanics, kinds of things. And so that's a really big deal. Of course, while we're modeling the cutters, let's model quantify the toughness of the cutter, again, in that tangential direction. So that was my number 3. And my last one is on, number 4 is on sensors, both standalone memory-based subs. Man, I tell you what, my eyes are open. I've worked in that space 20 years ago plus, but I'm seeing a tremendous amount of value, because when you're drilling in unconventionals, I can't always afford to have a live feedback to the surface just because of the cost of the environment. But it's almost always worthwhile to have a real low cost vibration sub. Let me know what's going on, not only while I'm drilling, but while I'm making connections, etc. And then of course, integrating that to the BHA so that I can transmit a little bit about what the rock strength is or the condition of the bit, etc. Would be really nice, so that I don't have to wait until the end of the run to see. But today, if I've got 10 rigs drilling in a given area, it turns out that if I learn on one, I pull the sub out and I download it and I learn, I still have 9 others that are still drilling, and I can make those changes. So it's not bad having I thought memory was going to be a bad thing or not adequate. It turns out it's probably more valuable than I had given credit to it. So anyway, I still think you have room for integration of sensors and into the BHA. Be aware, if you do that, if you tie it only to your BHA and yours only, you're going to get into the problem like some vendors did in the past, where you got to provide every single drill bit I need, all the bits, all the backup bits, all the options, one harder formation, one softer formation, one with a shorter gauge, one with a longer gauge. You know, you suddenly have committed, if your bit is the only way, it's the only one that I can run, you're going to have to give me a lot of options. So be aware that you probably need to integrate with the BHA, but it'd be nice to have a little short hop sub or some type that you can run with anybody's BHA. And that requires a little bit of protocol acceptance things, as opposed to saying, I'm just going to make it my own. So anyway, that was my 4.
Thanks, guys. We're running a little bit short on time. I think we're going to go to questions, so sorry about missing out on question 3. The first question comes from...
So it comes from Anon E. So what kind of rig site bit evaluation would you like to see?
I don't know if you guys heard it, but what kind of rig site bit evaluations are we talking about? Whoever, feel free to answer.
I'll start, and then I'll let these guys chime in. So I am working on this, Paul, and I'm working on a proposal to upgrade the IDC dull codes that we use, because they're not adequate to really tell you get you to the root cause and kind of make it more performance based. What I know that the rig site guys can't see everything, but if you give them good guidance, and if you give them a good forensics photographic records and package, or you do automatic camera-based diagnostics where it takes a picture and says, hey, that's a tangential fracture, and oh no, that one's spalling, and the spalling is likely, you know, if it's on the shoulder, it's likely due to whirl. If it's tangential on the nose, it's likely to drill through an interbed, and you can automate all that and give that guidance. So either some, if you will, not spreadsheet, but a photo guide that helps people pick the next bit in the ground, or an automatic detection is where I see us going. And we've got, oh my goodness, the level of expertise that we have out in the field is nowhere near what it needs to be when it comes to forensics. So, in fact, even in some companies, it doesn't even exist within their company. Even some of the big companies, they don't really pay as much attention. In fact, actually, a couple of smaller companies I have been phenomenally impressed with. I say smaller in total, but not one of the big three, big four kind of thing. But they still are good companies to record what's going on and take really good photographs that they can then use. So, and by the way, we're photo driven. I mean,
yeah.
The old IDC DO code is not enough. So you got to have pictures of the bit, the BHA, and all the stabilizers.
Thanks, Paul. I got another question from here from David.
Yeah, so my question is, for the operators, what's your appetite for being able to support a third-party independent record database as opposed to having to be dependent on just the service providers trying to collect each other's data?
Question, if you couldn't hear it, was openness for a third-party bit record collection database. Dustin or Gabe, you want to start off with that one?
Yeah, so I really can't comment for Shell as a whole, and I could only speak for myself as I would be all open to that, especially for U.S. land. I don't think there's any major secrets out there that need to be withheld in terms of bit records. I guess within reason. So, however, working for a very large major oil company, I would tell you that those type of sharing agreements often become quite complicated and often never are executed.
Yeah, I would agree with that. And the first question that I have coming from U.S. land shell market is like, who's going to pay for it?
Corva.
There you go. It's not high on my list either, guys. I mean, I go to if I have to go to 3 or 4 or 5 bit companies and say, give me all of the records that you have in this area drilling this formation. I get it. It takes, it may take a few days to get there, but most of these companies, actually, well, let me back up. The companies that have a higher priority of getting our business have all of that data. Maybe only on their own, but they've got it. And if I have to go to 2 or 3 of them, that's okay.
Okay, thanks. I'm told we've got to wrap this up and move on to the next. But Gabe, Dustin, Paul, thank you for your time and all the insight for the panel. Appreciate it.
Thanks for having us on.
You bet.
Thanks for the opportunity.
Thank you.